Quick revision video on amount of substance calculations involving reacting masses. So we'll start with the essentials. First thing, the formula triangle that links mass, moles and MR. Now these calculations are often based around balanced equations, and the equation will be balanced for you in the exam paper. That's because if you make a mistake balancing the equation, that's obviously going to feed into your answer. So I follow 3 steps. Step 1, moles of known chemical. So that's the chemical that you are given the amount for in the question. So that's mass in grams divided by MR gets you the moles. We're then going to use the mole ratio to calculate the moles of the unknown chemical. So in other words, the chemical that we're interested in finding out something about. So 3 steps, moles of known, moles of unknown, and then just go and answer the question. So we'll just finish this slide with some top tips. In calculations, keep the full number in your calculator. If you are asked to calculate anything along the way, maybe some moles or something like that, quote your answer to 3 significant figures. But remember that full number is still in the calculator. You should only round at the end of the calculation. And often the question will say round to an appropriate number of significant figures, or it might actually say give your answer to 3 significant figures. So here's the first question. What mass of sodium chloride is produced when 10 grams of sodium carbonate reacts with an excess of hydrochloric acid? We've got to give our answer to 3 significant figures. There's the balanced equation, and there's the moles, mass and MR triangle. So step 1, moles of known chemicals, obviously that 10 grams of sodium carbonate. So that's mass over MR, 10 over 106, 0.0943. That's to 3 significant figures. I've got the full number in the calculator. Mole ratio now to get the moles of unknown. So you can see that it's a 1 to 2 ratio. So we've had to double the moles of sodium carbonate to get the moles of sodium chloride. So that's coming at 0.189. And then answer the question, what mass of sodium chloride? So we need to just turn those moles into grams. Mass is moles times MR. So it's 0.189 times 58.5. So there's the beginnings of the calculator value, and to 3 significant figures that's 11.0 grams. So there's 2 for you to try if you want to pause the video and then play on when you're ready. So first question, just put the formula triangle up there. 12 tons of hydrogen gas, that's obviously the known chemical. So 12 times 10 to the 6 grams divided by the MR of hydrogen, which is 2, gives us 6 times 10 to the 6 moles. The unknown chemical is the ammonia here, so we need to multiply the moles of hydrogen by 2 over 3 to get the moles of ammonia. So that's coming out at 4 times 10 to the 6 moles. So to answer the question, we need to calculate the mass in kilograms of ammonia. So we need to turn these moles into grams first and then convert to kilograms. So mass is moles times MR. So that's 68 times 10 to the 6 grams. And then we just need to divide that by 1,000 to put it into kilograms. So it's 68,000 kilos. So final question, there's the mass moles MR triangle again. Known chemical, 40 kilos of iron 3 oxide. So we've got to put those kilograms into grams first, divide by the MR, and we get that many moles of iron 3 oxide. Remember the full numbers in the calculator. This time we're going backwards, so we need to double that to get the moles of iron, which is our unknown chemical. And then we need to calculate the mass in kilograms to answer the question. So that's moles times MR. That's going to give us an answer in grams at first, and then we just need to convert to kilos in this case by dividing by 1,000. So the answer was 28 kilograms. We'll just finish with this summary slide. So we've got the mass moles MR triangle, which you've got to remember. Mass has got to be in grams. So the first thing you do is calculate the moles of the known chemical, mass in grams over MR. Use the mole ratio to get the moles of the unknown chemical, and then answer the question. Obviously this video is about reactant mass calculation, so all of the answers have been calculate the mass, but I've just varied the units that they're in just to mix it up a little bit.